Welcome to Klein's Geometry and the Law of Cosines. Last class we talked about the law of sines, where if you didn't have a right triangle, you could still find side lengths and angle measures as long as you had one relationship where you knew an angle measure and the side across from it. Now we're going to consider what to do if you don't have this. What if you know side angle side or side side side, but you don't have a side and angle across from each other? How then will you solve it? The proof is posted on the Moodle. I don't want to get into that here. I would like to show you how to use this law. But what the law says is any side length at all, so we're just going to go with side length C, that side length squared equals the other two side lengths, A squared plus B squared, minus 2 times A times B times the cosine of C. C has got to be the angle across from the side. Okay? So C squared, it looks like a big deal, but it's really not once you figure out an angle and a side that are across from each other. Okay? So let's use that law of cosines. What if we wanted to find AT? Well, I would first say, what do I know the angle across from AT? And I do. It's 62 degrees. So using my law of cosines, I would say AT squared equals, and I just use these sides, the two that I know, 9 squared plus 14 squared minus 2 times 9 times 14 times the cosine. It's got to be the angle across from AC, so the cosine is 62 degrees. That's all you're doing. The biggie is just the setup. Get the side squared that's alone on the left of the equal sign across from the angle, cosine of the angle. And then you're good. Do not, at this point, try to do anything mentally. This is kind of a big deal, and you know it's not going to be rational anyway, because you've got a cosine ratio. So I would check my mode first, turn it on. I'm in degree mode, so it's all good. Make sure you're in degree mode. I'm going to clear this screen, and now I'm just going to type this in exactly as I wrote it. 9 squared plus 14 squared minus 2 times 9 times 14 times the cosine of 62 degrees. And then check and make sure that it's all exactly like you wrote it. Press enter. That is AT squared, folks, and you need AT. So the next thing you're going to do, the opposite of squaring, is square rooting. So AT is going to be about, now here's how you do this, second x squared. That says we're going to square root. Now do second again, and come down here to the minus sign. Can't see. That minus sign, I'm going to press that here. And that, now I'm going to square root my answer. I'll press enter, and we'll see 12.597, so if I'm rounding to the hundredths place, 12.60 is the approximate length of AT. Okay, so that's all you have to do when you're looking to find a side length. Angle measures, a little trickier. If I have the side and I want the angle, let's say I want angle T. Oh, excuse me, I don't have a T here. Let's say I want angle F. What I'm going to do is say what side length is across from angle F. And that's the side that will go on the left of the equal sign, 11 squared. The other two sides, 7 squared plus 13 squared minus 2 times 7 times 13 times, and now I've got the cosine of f because it's across from the 11. This you have to actually work out. So the next step, squaring 121, 49 plus 169 minus, oh, I'm lazy today. So I'm going to say 2 times 7 times 13 and get 182 cosine of f. So you're going to treat this as if it was a variable. So you just solve it like you would any equation. And next step, add these, 49 plus 169. Notice nothing else changed. And we want this alone, so I'm going to take 218 away from both sides. And I've got 121 minus 218. This will always be negative at this point. That's a 0. Now the opposite of this multiplied to this is division. So we're going to divide both sides by 182. Now notice, negative 97 is already in my calculator. So I'll just press divided by, and it says, okay, divide that 197, or that 97. And I'm going to say negative 182. Press enter, and I have a big messy ratio. I'm going to call that approximately equal to the cosine of f because I rounded. But I'm not really going to round. You know, we want an angle measure. We want to find the measure of angle f, so I need the inverse cosine of that ratio. That would cancel that out. And I've got the measure of angle f now. And if I take the inverse cosine of this ratio, I'm going to do second cosine, and then second, and again come down here to the minus sign, and that brings that ratio right in there with no rounding error at all. Press enter. So now I see that this angle, we always round angles to the nearest degree, 7, so I'm going to bump that up to 58 degrees. Okay? So when you're doing, bump that up to 58 degrees. When you're doing, finding an angle measure, set it up, then go ahead and square everything, and then just solve for the variable. Okay? Add your like terms, take away the 218, divide by the coefficient of the variable. But when you get this messy ratio, you're not done. That's not your angle measure. Take the arc cosine or the inverse cosine of your answer and round to the nearest degree. So, two ways to use the law of cosines when you're looking for an angle measure. Always arc cosine. You're going to need that inverse cosine. When you're looking for the side length, just put everything in the formula, run it on through, and square root your answer. So, hope this helps. Enjoy the law of cosines, and I will see you in class.